Spectrometer determination of wavelength of mercury spectrum using grating experiment. So first let us see what are the parts consist of spectrometer. The first one is the telescope. This is the eyepiece. The next one is the grating table or prism table. The third one is the vernier table, which consists of two scales. One is vernier A and another one is vernier B. And the third one is the collimator. So this is the adjustment screw. Using the screw only we had to adjust this collimator. The last one is the source. It's a polychromatic source, or we can simply say it as a mercury vapor lamp. This is the grating. Using this grating only we are finding that wavelength of mercury spectrum. So in which it consists of 15,000 lines per inch. This grating is used. So first let us do some initial adjustments in the case of spectrometer. The first adjustment is the telescope adjustment. So we had to do this telescope adjustment. First we had to focus the distant object. So our depends upon our human being. So depends on the humans, our eye power is changed, so we have to do this adjustment. The next one is the collimator adjustment, so in which it consists of two parts. The first one is the shutter. So first we have to open this shutter. The second one is we have to adjust the width of the slit. So using this black color knob we have to adjust the width of the slit. So before we are doing this collimator adjustment, first let us confirm whether the shutter is open or not. And using this black color knob, we have to adjust the width. Then we have to see this direct ray through this collimator. So if you are not getting the clear image of that slit, we have to adjust this collimator screw. So you are adjusting the screw means you can get the clear image of the slit. This is the important adjustment. So once you are getting the slit, it's like a very thin slit. So how to adjust the slit? We had to use that black color screw to adjust the width of the slit. So once you are getting this direct ray, we have to coincide with the crosswire. So how to coincide with the crosswire? By using this telescope. The next adjustment is the vernier table adjustment. So after coincide with the crosswire, we have to rotate this vernier table. We have to fix this vernier scale 0 of the vernier scale coincide with the 180 degree of the main scale, and the other side default the vernier scale 0 coincides with the 0 degree of the main scale. So this is the third adjustment. So this is the way we have to coincide this two lines. So next let us move on to that experimental part. After doing this adjustment, next we have to rotate the telescope through 90 degree. The first step of this experiment is, first let us rotate telescope through 90 degree. So what happens? One side of this vernier scale 0 of the vernier scale coincides with the 90 degree of the main scale, and another side 0 of the vernier scale it coincides with the 270 degree. After doing this one, we have to fix this telescope as well as vernier table. So like this only, we just coincide the vernier scale 0 with the 90 degree. The next step of this experiment is we have to place that grating on this grating table. So for this case, we are preferring this 15,000 lines per inch of the grating. The next step is we will place this grating on this grating table. So now the grating faces this collimator. Then after that, we are rotating this grating towards this telescope until we are getting one reflected ray. So when the light falls on the grating, due to this reflection, you are getting one reflected ray at the angle of 45 degree. So after getting this ray, you must coincide with the crosswire. So the light falls on that grating. Due to that reflection, you are getting one reflected ray as that of our direct ray. So we are adjusting this grating. We are coincide with this reflected ray with the crosswire. So the next step of this experiment is we are rotating this vernier table through 45 degree towards this collimator. Because by means of this normal incidence method, we are finding this wavelength of mercury spectrum. So after rotating this vernier table through 45 degree, you are getting vernier scale 0 is coincide with the one side. The vernier scale 0 coincide with the 45 degree of the main scale, and the other side vernier scale 0 coincide with the 270 degree.
ஆரஞ்சு எல்லாம் தெரியுது. போதுமா? ரீடிங் அப்படியே காமிச்சிடும். ரீடிங்
$295.
கிளாரிட்டியே வர மாட்டேங்குது. $296 என்னமோ இல்லை. சரி எழுதிருங்க எழுதிருங்க.
என்ன போடுறது?
கவனம் போடுமா.
வரும் நான்
எழுதுங்க. டேரக்டாக எழுதிடுங்க. 0 90
வருமா?
90 இந்த பக்கம் 90 வச்சோம். MSR 90